Okay, so these two sections, and then we'll do like normal, do the lesson quiz tomorrow and the multiple choice, and then we'll review and take a test and be done with the probably by substitution elimination type thing with word problems. Okay, so these are word problems again. I didn't want you to have to rewrite all of these word problems, so I just put them on the paper. If you want to write on this paper, you can write on this paper. Okay, and then if you feel like you need more room, then you can add it on to some other stuff. But I gave you enough room to write some stuff. But if you're a big writer, maybe that's not enough room for you. Okay? Totally up to you. So you might want to get out another sheet of paper. Also need a calculator, because it's still a lot of the same stuff as what we did the last time. Okay, here we go. Okay, so the first ones that we're going to do are mixture problems. Okay, and then the second objective, number 53, is going to be motion and distance problems. Okay, so starting off, okay, and you have this one in front of you, which I know it's like super duper small on your paper. So I forgot to put another one here. We're just going to say this is the first one. So if you want to label it on yours, you can.
So you reach for that folding down.
Not if you have that paper in front of you. So it's on there, so you can just write on that if you want to. Okay, so tickets to a local movie were sold at $5 for adults and $3.50 for students. If 400 tickets were sold for a total of $1,565, how many adult tickets were sold? So we're going to write two equations again, okay, in both of these sections, just like we did in the last one. So you're going to use substitution or elimination, okay? Definitely probably not a graphing one, okay, like what we could have used in the last one, okay? So we're going to have two separate, when we do the mixture, you're going to have your total statement. So the information that they give you always gives you the end part, okay? And then you're going to have your mixture statement. Those are the two statements that we're going to use. Okay, so our total statement is we have adults and we have students. So I'm going to use an S. Okay, so if I have, we're ignoring how many total were sold. If I sold 10 students and 10 adult tickets, how many total tickets did I sell? What did you do? Okay, so we don't know how many are sold yet. So we're going to start with the total. We just know that we're going to sell adult tickets and we're going to sell student tickets, right? Because we don't know how many of each yet. Okay, but we do know that when we find that out, that there's going to be a total of how many of them sold. Okay, so we have our first statement written. And again, I'm going to do samples of all the ones that you have, so as long as you can follow and find where we got that. Okay, now we're doing the mixture, where we know the other bits of information that we can put with that. Okay, how much were the adult tickets? 5. So if I only sold one, it'd be $5, right? If I sold 2, then it would be what? 10. So what did you do with 5 and sold 2 tickets? What did you do with that to get 10? Multiply. Okay, so we're going to write it as multiplication. Okay, you don't need to write the 5.00 as 5 because there's no sense in it. Okay, so however many tickets, adult tickets I sell, I know I'm going to multiply it times 5 because that's how much it costs, right? Okay, what am I going to multiply the student tickets by? 3.5. Okay, I can just drop those zeros on. Okay, so 3.5, and then student tickets. Okay, so now, again, I don't know how many I sold adults, how many I sold of the students, but I know the total price was how much. Good. Okay, so now we're at where we were at before, where we can solve. Okay, they wanted to know. Let me go back over here. It's not the question on my paper. They want to know how many adult tickets were sold. Okay, so that means that we're solving for A, right? We're going to solve for A. So that means we want to plug in for S. Okay, we want to replace the S with the information so that we just have A. Okay. So if I'm gonna do that solve for S and I move this to the other side, that would mean I would have S equals what? 400 minus A. Okay, now if you don't catch that, you just start with one of them. Say you started with the A and you went 400 minus S. You still are gonna get the same answer. You're just gonna do like what we did before, I think it was age, where you solve for Todd and Tom. And you might have solved for Todd first, and then you saw that they needed Tom, and you just go back and plug it in. Okay, so just pay attention to which one you're solving for. Okay, so now I can do substitution. Okay, so I can plug this in for S. Okay, so I have 5A plus 3.5 that I'm going to multiply times 400 minus A. Okay, so we're going to have 3.5 times 400. We get 1,400. Okay, and then I distribute that, so that'd be a negative 3.5A. Okay, then subtract our two like terms. So I'm going to go 5 minus the 3.5, which gives me 1.5A. And then I'm going to move this over right, subtract it. So 1565 minus the 1,400. And then divide by 5. One tick. Okay, now that was for the adult tickets, right? So if they wanted the student tickets, okay, you can plug it back into here and subtract from there, or back up to here. Okay, you'd plug the adult one in, which is subtracting to get the student one. So this doesn't matter again. If you got the A or the S, just go back and make sure you got the right one. Good so far? Okay, next one. And we'll put this one as number 2. Okay, so peanuts sell for $2 a pound and cashews sell for $3 a pound. How many pounds of each need to be mixed to sell 10 pounds at $2.40 a pound? Okay, so remember we have a total statement and then we have a mixture statement. Okay, similar to the one that we just did, except now we have, instead of adults and students, you have peanuts and cashews. Okay, so peanuts and cashews, just like adults and students, you're just going to add the two mixtures together, right? I don't know how much I have yet. Okay, we're going to go peanuts and cashews. To get a mixture of how many total pounds? 10. Okay, so just like the last one we had adults and students. Okay, so now just like the last one, now it's per pound versus the tickets. Okay, so peanuts were how much? $2. Okay. Cashews, $3. Okay, now the only difference on this is we want to convert this because this is per pound, okay? And we already know how many pounds we're going to have. So if I take this and multiply it times this, because this is just for 1 pound, we don't want to put 1 pound there, okay? We want to put the total amount of pounds. So this one's easy because it's times 10, which means we would just move the dollar or the decimal over one spot. Okay, so it'd be 24, right? $24. So that'll be the only catch different from the last one. Okay, we need to know the total amount of dollars that it's going to cost for those. Okay, again, it doesn't matter if you solve for P or C, you just need to go back and see which one, but this one needs both. Okay, so we have to solve for both of them. So I'm just going to get to P by itself. Okay, so I would move this over to the other side, so that would mean that P is equal to 10 minus C. Okay, and then we would plug it into solving for P. So I'd have 2, 10 minus C plus 3C equals 24. So 20 minus 2C plus 3C equals 24. Combine my like terms, so that's going to give me a C, right? Which I've already solved for C basically, and there's a 1. Subtract my 20 over to the other side, so there would be 4. So 4 pounds of cashews. How many pounds of peanuts? 6. And they wanted both. So 4 and then peanuts. 6. Okay, and the easiest one would be to plug it back into that one. Okay, you would plug it into that one because it has to work, remember, in both equations when we solve. Okay, just one of them is going to be easier than the other. Not too bad so far, hopefully. Kind of same pattern, just different things. Adults, peanuts. Okay, this one a little bit more different. Okay, we'll just label this as number 3. Okay, a solution of 68% vinegar is to be mixed with a solution of 21% vinegar to form 329 liters of a 40% solution. How many liters of a 68% solution must be used? So this one's just a little bit different, okay? We still have 2 different solutions that we're mixing together, okay? So you can make it X and Y, I'm gonna make it A and B, okay? I'm gonna be mixing together A solution and B solution to get a total amount of liters. Remember our total statement is our first one, okay, which would be 329. Okay, so my first solution, and again, it doesn't matter which one's your first one, which one's your second one, there's 2 different solutions. How do I change that to decimal? What is 68%? 0.68. Okay, so my first solution, I'm going to make it as the 0.68. Okay, so I'm going to add with which one? 0.1. What's the other second? 0.21. A little dyslexic today. Okay, now, this is like the last one where we have to convert, okay? Because I need to figure out what 40% of the solution is with them mixed together, okay? How would I figure that out? 40% of a total. Multiply. So we're in Idaho, right? We pay tax, so it's 6% on your dollar. So however many dollars you're spending, you multiply it times 0.6. Okay, so this is the same thing. Okay, we're doing 40% of the total solution. So we went 300, and I'm just writing this small so that you know where this number came from. So it's 329 times 0.4. You could put in 0.40 if you wanted to. That would be the same thing. Okay, what did you get in your calculator? 131.6. So that's where that came from, so that we know. So taking total percentage that they're saying that it's going to be of that. And of means multiplication if you've learned that in previous classes. Okay, so this one, they want us to solve for, and if you notice, and again, remember, it doesn't matter if you solve for the A or the B, just go back and check it. But they want us to solve for the 68% solution. Okay, so when it's like that, that means we want to get rid of this one. So we want to solve for B so that we can replace the B. Okay, so to replace the B, that would mean I need to move that over to that other side. So that would mean B is equal to 329 minus A. Okay, and then we're replacing the B because now we're solving just for the 68%. What did you get on that 0.21 times 329?
69.
Yeah. And did you get 0.478? And you subtracted? Okay. Make sure I got mine. Anybody get it yet? 133. So again, if we wanted the B solution one, then you could just plug it back up into here and subtract it over into that one right there. Okay. And subtract it over to get the other one. If they wanted both of them, then you would have it. Okay, good. Okay, so you are going to try no Pledlight. One more. Oh, I had a blank page on my notes. One more. Number 4, and then you're going to try some. Okay, so number 4. How much pure water must be mixed with 5 pints of 90% developer to produce a mixture that is 33% developer? Okay, so this one a little bit different. We're not going to have like an A and a B and a developer and a water. Okay, I already know how much developer I'm going to have, which is how much? How much? In that sentence. How much developer? Because it says how much water must be mixed with, how much developer do I have? How many pints? 5. Okay, so I already know the developer. Okay, so I don't have to give it a variable because I already know how much I have of that. Okay, it's going to be mixed with what? Water. So we'll just put W. Okay, to stand for the water. Okay, but then this time, this is where our second variable is coming in. We don't know about the mixture yet. So before we had 2 variables on the left-hand side. Okay, they're split up this time because we already know one of them. Okay, so we have our total. Okay, we have the total formula. Okay, so now we're going down to the mixture formula. Okay, how much of the developer percentage-wise did we have, or did we mix together as a decimal? How do we write that? 0.9. Okay, so we're going 5, and it doesn't matter which one you're writing first, times 0.9. How much developer did we mix with the water? Did we mix any developer with water? What word in there gives you that away, that you're not mixing anything with it? Pure water. So you're not mixing anything with it, right? There's not going to be a percentage of developer in there. It's pure water. Okay, so we're not mixing anything with it, so that would be represented by 0. Okay, so really, if I have this, what happens to the W? It cancels out. It goes away, right? Because we're not mixing anything with the water. Okay? There's no developers, not a percentage of anything to get the mixture. So now this makes this pretty easy. Okay, because we're just solving for M. Because the W went away. What do I do to solve for M? Because the W went away. Multiply it. Oh wait, I lied. I forgot about the 33%. Step back. Sorry, I forgot about that. How much percentage of mixture do we have? How do I represent that? What? 0.33. Okay, we had one extra. We're still solving for M. Okay, so I would multiply those guys and get what? 4.5. Okay, and then my last step is just to what? Divide by 0.33. Which gives me what'd you get for M? 13.63. It probably repeats, right, on there. Okay. So M equals 13.63. Okay, now if you go back up here, they want to know how much pure water that you have. We need to solve for the mixture. Okay, so if I plug the mixture back up here to solve for pure water, because there's nothing added to the water, what are you going to do with that 5 and the 13.63? Subtract. Okay, so pure water is going to be what? 8.6. Oh, you got it? Yes? Calculator? Make sure I got it there. Yes. Okay, so all of those on the water one, there's not going to be anything ever mixed with the water. So just know that every single time, water is going to go away and you're solving for the end. So you just need to pay attention to the percentages and making sure all of those percentages and numbers are into your equation. Not forget about it. Okay. Okay, now you're going to try it. So on your paper, and I'll have it up here so if you can't read it, and I don't care if you do it on a separate sheet of paper. Okay, you're going to try each one of them. Okay, by looking back at your notes. Okay, answers up here on the, so check them. So for 47, the water should have been 13. You may need me to go over that to see what I did wrong. Do that one, okay? Start with that one. Yeah. Okay, so, no other question. How much water must be mixed with 2 pints solution? Okay, so we already know that we have 2 pints, right? Just like we did with the example, we had 5 pints, right? So you're gonna have the 2 plus the water equals a mixture, right? Just like this. Let's just get that. Okay, so then the next part, we know that we have percentage-wise of the 2 pints, we have 90, right? So we're gonna multiply that. And then remember I said we don't mix anything because we want pure water, so really the W goes away, okay? But now the percentage you'll say in the sentence of how much of the mixture you need as well. I don't have a question. 12. Okay, so you're just solving for mixture. So you multiply those 2 together, you get 1.8. Okay, and then divide by 0.12, divide by 0.12 to get the mixture. Okay, so you probably got 15. Okay, but then they want pure water. So now you've got to plug the 15 back into the mixture. Okay, and then subtract your 2. Which will give you 15. Oh, okay. So you probably did the steps right. Just said they're not first. Okay. What about the second one? So the second one, you had peanuts and cashews. Are we okay with that one? No? Do that one? Yeah? Okay. Okay, so we have cashews and peanuts, just like the example that I did. We don't know how much of each. Okay, but we know our total is going to be how much together? How many? 80, right? Ounce. Okay. We know how much the cashews cost. So we multiply that times however many pounds. We know how much the peanuts cost. Okay, but remember, this one is the one that is not per pound. What's on there, we have to multiply it because we already know how many pounds we're going to have. So you had to multiply what times 80? 3. Okay, so we went 80 times 3 to get this number, okay, which is 240. Okay, then from there, because you have to solve for both, it doesn't matter if you solve for the C or the P, you're just going to plug them in there. Are you good from there? Yes, okay. So you should wind up with 70 and 10. So my guess is you probably forgot to change it to the 240. Okay? What about that last one, 252? Do that one? Okay. Okay, so we have an A solution and a B solution. That gets us a total of 342. You got that part? Okay, so how much of the A solution, what's the percentage on that?
0.9.
Right, so 0.59 A. And how much of the B solution? 0.21. Okay, so remember of this one, you've got to multiply it times what?
It was
Point something.
0.49.
0.49. Okay, so we have to multiply that times 2.49. Did you do that?
Yeah.
Okay. So you should got 167.58. Yes? Okay. So I think from this one, question for you. So they want the 59 solution, which is the A. So we want to replace the B to get rid of the B, so we can solve for A. Okay, so if we're replacing the B, then you would move this over, right? So that you can plug that in. Did you do that? Okay, so I'm going to write that part out. So you have 0.59A, and then you would distribute the 0.29 to that and that, right? And you should get 71.82 minus 0.21A equals 167.58. You got that?
Yeah.
Okay, so now we're just solving for A, so it must have messed up something. This part. So subtract those two, you get 0.38A, and then subtract that over to the other side, which gives you 95.76. You still good. And then you're going to put this number in first, divided by 0.38.
That was it?
This, you had 96?
96.14. That was it?
That must have been it. It's 252. So you should type in your calculator again. 95.76.
Yeah.
Oh,
95.76 plus 0.38 is 92.
Oh.
I'm sorry.
That's okay. So you did it right. You just hit the wrong button. Right. That's okay. 95. Right. 95.76 divided by. Did you get 252 now? Yeah, okay. Okay. All right. So this last section has to do with motion. Okay, you don't have to, this is already on your paper. And motion is distance equals, what do you think that R stands for? Rate. And what does T stand for? Time. So rate and time. I'm thinking you probably had this in science, and we talked about distance and speed and all that kind of projection type things. Maybe not pay attention, but okay. So you don't have to use this chart. Okay. I like to use this chart because I lose track of like what I'm putting where. So it's totally up to you. You don't have to write this chart every single time. Okay. I just like to be organized and know where I'm moving my numbers and doing things. Okay. So that's already on your notes. Okay. So we're starting with number 1 on the, this is objective number 53. Okay. Train A leaves a station traveling at 64 kilometers per hour. 8 hours later, train B leaves the same station traveling in the same direction at 84 kilometers per hour. How long does it take train B to catch up to train A? Okay, so we have, okay, we have a train A and we have a train B. So it's similar to some previous ones where we have 2 different equations that we're looking at, okay, that we're going to write for. Okay, we don't know on the train A and train B how far they're going. We just know they're going the same distance, okay? So I'm just going to put B, and really these are separate, so it's be like if you wanted to do 2, but we just know that they're going the same distance, so they're going to be equal to each other in the end, okay? Rate is going to be the speed that they're going. So train A is going how fast?
4.
Kilometers per hour. Okay, so that's going to go in here. Train B is going how fast? 84. Okay. Okay, I don't know on train B, I don't know how quickly they're getting there, but train A gets there how much more quicker? Right, 8 hours before. So you can flip these, you can do a minus on here, but we don't like to work with subtraction. Okay, train A left ahead of time, basically. We good? Okay, so distance equals rate times time. So I have my two equations. I have distance, so I'm going to do B first, just because I don't have to have any extra stuff on there. So this is train B. So distance equals rate times time. So that's just going to be 84t. What do I have to do with train A?
84t. Wait, one parentheses.
Right, times. So this is going to be in parentheses when we go to write it. So this is train A is 64 times t plus 8. Okay, so that means we're going to have to distribute. So we have distance. Actually, no, we don't need to do this. Let's take a step back. We already have substitution going on right now. Okay, because we know that the two of them are going the same distance. Okay, so I can take this and plug it into this and then do that. Okay, because the distances are equal to each other, so that means that the distance of this one, whatever it winds up being, I could replace it for the distance in this one. Okay, so I'm going to have 84t equals 64t and 64 times 8. What do you get? 512? Yes? Just make sure I get it. Okay, move my 64 over. Divide by 20. Good. Okay, so now back up to the question, just to make sure we answered it. It says, how long does it take train B to catch up with train A? Okay, well, train B, if I were to multiply this times this, right, that would tell me the what? Because that's not what they're looking for. If I multiplied 25.6 times 84, that would give me their what? Distance. Okay, they weren't looking for distance. They wanted to know the time. Okay. If they wanted to know how much longer it took train A, if I plug this into here, then all I have to do is add the A part, okay? But they didn't. They just wanted to know for B how much longer it's going to take for it to catch up. And that was the T right there. Okay. All right, so we're circling that one. So just pay attention to which one. So if it's T and they want the time for A, you would plug it into that one. If they want distance, then just plug in time, depending on which one they want the distance for. It's going to be the same, right? Because they both want the same distance. Okay, now we're flying. We're off of trains and going to planes. So this will be number 2. Okay, if I were swimming instead of in the air, and I was on a lake that was totally still, okay, and I could swim 1 mile per hour, okay, if I all of a sudden have a current that is behind me, is it going to make me faster or slower? Faster. Okay. If I'm swimming and it's a still lake and all of a sudden the boat's in there and the waves start coming at me, then it's going to make me slower. Okay. So the same thing with the plane. Okay. You're going to have tailwinds that are going to make you faster. Okay. And then you're going to have things that are going to make you slower. So it's going to change what we're plugging in from the rate. Because your rate's not always going to be 1 mile per hour. It's going to depend on whether or not you have still water or not, okay? So we still have distance equals rate times time, okay? We're gonna have, I'm gonna put width here, so this is with wind, so behind you, you're gonna be going faster. If you're against wind, then you're gonna be going slower, right, in the plane. Okay, this time they tell us that the distance that we're going, which is what? 900. Okay, so both of these, we're still, regardless, if we have wind in front of us or wind behind us, we're still going 900. Okay, my rate with wind is going to now have a current that's going to speed things up. What do you think this one's going to be? Subtract, because it's going to slow my rate down. Okay, so when I have the speed working with me, how many hours does it take me? 3. When it's against me, it takes me 4. What time are we supposed to bring it in?
11:16.
Okay.
One interesting
Do what?
thing.
Okay, what is the plane speed in still air? So we're gonna have to solve, okay? I don't know if I want to get going on this one. We're not gonna finish this one before the bell rings. I'm gonna pause here.